Sharing again. All right, I think I'm recording now. You're all being recorded, so don't say anything you wouldn't want to. Yeah. Anyway, desktop 2, share. All right. Yeah, that might be better. I think we're recording and we're sharing. Project 2, performed a grid shell. We talked a little bit about this on Monday when I said that we would start shifting from, let's say, curves, points, lines to surfaces. Let me just pull up this chat. Yeah, good morning. All right. Morning is here. Morning is here. Introduction. In Project 2, we will generate and build a performed a grid shell system. Not a big surprise by this point. Understand how to leverage parametric design, geometry, performance, and digital fabrication. So we're going to talk about some design moves. But really, it's sort of a design process that takes full advantage of, let's say, doubly curved geometry and its structural capacity, because that's what shell systems are really good at. We'll talk about designing towards performance, and actually, instead of just sort of designing something and measuring how well it does, like let's say with shading or something, we'll actually close that loop and make it a sort of feedback-informed process, wherein the performance data actually becomes part of the design determinant, right? So we'll actually plug that data in to help make some of the design decisions and as parameters. And then looking at production. So, not just making something and showing what it looks like and then saying, here, hand it off and build it for me, please. But actually thinking about all those steps downstream about how each individual part would be cataloged, fabricated, shipped, and then assembled. And so the representation will reflect that. The end results, I'm sure you'll see, because you'll actually have to build it yourself. Just like a piece of furniture from IKEA or something, you'll have to make the instructions for it as well. Because you'll have hundreds of pieces and they'll all be different, and you'll need to know which one's which and where it goes, and think about the sequence of how they're put together. You'll have to do that twice. Anyway, objectives. We just touched on a lot of these, but it's, again, we're talking about integrating performance criteria, right? So when I say performance, I'm not talking about, putting on your unitards and dancing around. I'm talking about, sort of how would your grid shell perform relative to some sort of criteria that we give it, right? So if you think about a high performance vehicle, right? You're talking about one that is efficient and works at sort of peak level. And so that's the general sense of how I'm thinking about, will I dock your grades if you put on unitards and dance? No. In fact, if you come up with a parametric design dance, more power to you. I suspect that you guys can make little, like, shapes of letters like T's and U's and V's, and you'll understand what that means here soon. But anyway, we'll start talking about how performance criteria and data can help generate the geometry that you're making. We'll talk about how production manufacturing constraints can also be fed into that design process, so that the stuff that you guys design actually has a sort of a material or a production logic to it. So in other words, it's not only does it look cool, but it's actually designed while thinking in advance about how it could actually be built, right? To leverage the underlying geometries and computational data structures, lists, arrays, data trees, in order to create a complex parametric model in a multivalent design space. That's a big, long list of words, but essentially we're talking about, again, making associations between the geometry and the numbers and the variables and the geometries that you produce and the data that you want to react to, right? Making it all look together in a nice complex way. Complex meaning dependent, interdependent. So, what you'll find is that instead of just making up numbers and variables, right, we can start to assign things based off of real world analysis and criteria that we need to use, right? And we'll be talking about different ways that all this data under the hood is actually stored and organized. So we've been doing some things with lists, right? Whereas, we can feed, let's say, a start point and end point, make a line, but it wasn't really that helpful until we could plug in like a list of 100 start points and a list of 100 endpoints and get 100 lines out like that, right? The economy of scale, kicking in with feeding a list of inputs, a list of ingredients, and then getting a list of executable results at the end, right? And that's to say that there's more ways to store those sorts of data than just a simple basic list. We'll talk about data trees in this project quite a bit, actually. To demonstrate abilities to generate and format explanatory design and fabrication representational drawings, right? So now we're talking about the sort of drawings to produce. And so, you know, one of the specific things that we'll do is actually produce an exploded axon, sort of showing the system as a set of pieces that can be assembled and put together in a particular way, in a particular sequence. But again, you know, we're always trying to, you know, hit multiple targets with one arrow. And so not only are we talking about parametric design, but we're also talking about generating and formatting the perfect, beautiful drawings as a result. Talking about graphic communication, design intention, constraints, results, as well as providing instructions for production and assembly, which you'll definitely need. It's like when you used to buy those, any of you guys like buy those metal car, plane, or train sets, and like you'd have to snap all those pieces off and paint them and then glue them together, and yeah. Those were a real pain in the rear if you didn't have the instructions, right? And so I think what you'll find is that there's, you know, nothing sophisticated can be put together without those sorts of instructions, and so that's what you'll be putting together. Demonstrate abilities composed of balance, graphic composition, working with the elements and principles of art and design. So in other words, you're going to have all these drawings, and how do you compose them on the poster in a nice, neat way. And to demonstrate abilities to design and make models through rigorous prototyping in order to dial in the tolerances with a parametric model to create a well-crafted and detailed physical grid shell model, a true design to production feedback loop, right? So you'll be prototyping this using laser cutting, manufacturing, and chipboard. And not only will you cut this and put it together once, but the first time you'll actually figure out how not to do it, and then you'll adjust things, complete that feedback loop, and make it that much better so that when you do it the second time, it'll actually go together really nicely and look awesome. Don't believe me? Well, here's some of the example outcomes from last year. Right, so you can see they're getting better at following the grid and how to sort of put these things together on a poster. This is Nicholas Meyer. I don't know if you guys know Nick Meyer, super stand-up guy. Kind of quiet, but you know, quietly gets his work done and really, really awesomely. And so, you know, again, he has these sort of information. Here's what it looks like. Here's how it goes together. Some ortho drawings. Axon. Here it is exploded. Here's the rib system, the skin system, the paneling. Here's a component or a catalog of the components. Here's a catalog of the ribs. Here they are exploded to show the sequence of how they go together. Here they are exploded, showing the sequence of how they go together. Here they are laid out flat for laser manufacturing, etc. Right? So you can see this sort of pattern. Here's another one from Nikki Huggett. You know, again, showing the sort of original shell, how it's broken up into this sort of grid shell structure, and then how it's populated with a set of components that respond to some sort of performance criteria that we set, which was in this case daylighting and creating shade underneath. Right. So we'll take this step by step throughout the next month, over month. Right. We'll finish this. If everything goes according to plan, we'll finish this by the beginning of November, and then we'll go move on to project 3. And of course, oh yeah, look at that. All of these laser cut prototypes. And trust me, a lot of the first iterations were complete disasters. Really made a difference sort of doing it once, figuring out what worked and what didn't work, and then doing it a second time. And you know, if you think it makes the laser cutter go faster, feel free to put on your unitards and dance around it in a choreographed way. You know, it's kind of interesting when the laser cutter motors go back and forth. It kind of makes a weird sort of cadence music anyway. I'm just waiting for somebody to sample that and remix it into some sort of weird rhythm. Anyway. And then the schedule in brief. So we are right here, as you know. And we're launching Project 2, and I'll talk a little bit more about that in a minute. We'll take a look at everything in detail in a moment. You guys were supposed to watch Akeem Menges talk about material computation. We'll talk about that in a moment. And so you can see there is a sort of cadence here on Monday. We'll talk about planar fabrication, and you'll have some other things to watch and do. and that short amount of time between Monday and Wednesday. On Wednesday, we're gonna have Kyle in. I don't know if you guys know Kyle, probably do. Really good guy. He runs the laser cutter and CNC router and all that kind of stuff, bench fab stuff. But he'll be here to give you guys the lowdown on everything you need to know about laser cutting, and including how the process of how it works these days, since we have to practice social distancing and make sure everything's disinfected. All small pieces ready to be assembled. Yeah. Good question, Julian. And so we'll talk about that more. After a while, you guys will have these grid shell ribs started and laid out, and you can start laser cutting things with notches and trying to worry about the material thickness. For the planer, then after Kyle comes on Monday, we'll start talking about the shading components, we will make it official. You'll have a week and a half or so to get that physical prototype, that first physical prototype prepared, and try to put it together and photograph it. Photograph both your successes and failures. We'll talk more about the performance side of the shade components. So the way this works really is that we try to get you up and running with designing this thing, using all the tools, preparing everything for laser cutting, and then while you're fabricating things, and really it's just sort of a waiting game when you have your appointment, and then trying to put it all together. In class for the second half, then we're taking all of those drawings and information that you've produced, really formatting them into the proper drawings and catalogs and instructions that you need to do everything. And we'll also be talking about how do you take the performance stuff and start to create the diagrams out of it. So a lot of this is sort of in parallel with, the fact that you might go and spend half an hour at the School of Architecture getting your stuff laser cutted and bringing it home and trying to put it together one night or something. In class we'll be debugging, going through that process. Trying to work through any problems you're having with that process, but also preparing all the drawings and diagrams that you need to complete the process and to turn in the poster along with your model. Okay. By the end of project 2, drawings composed on a board as well as a final physical prototype. So this is, let's say, someone's physical prototype, and this was their board, right? It would probably help if I had my annotation tools up. Here we go. This was somebody's board, and ta-da, this was their model, right? Or something like that. Okay. Now I like to take photographs of everything and arrange them in grids, and they look really awesome and sweet when you have like bazillion grid shells all at once. But not to say that you're going to make like 80 grid shells a person. This would be yours, right? Or this would be someone else's. Okay, so just want to make that clear. All right. And so in the spirit of actually utilizing Canvas maybe a little easier on the eyes now, for module 2, each week I'll just create a new page. That way we don't have to scroll through countless YouTube videos that are embedded in the thing and feel like you're scrolling all day just to find the right place. So if you go to project 2, week 1, which we're at the end of, yay. Right, again on Monday we talked about rethinking materiality through computational architecture, and we'll talk about that in just a sec, right? But now we're going to talk about surfaces, and so in a similar way, you're going to have some videos to watch, and then follow along and produce some of this stuff. I'm not actually going to ask to see any screenshots or anything of this stuff from you guys. I'm just going to let you. I'll do the honor system. I'll just assume that you guys want to learn, since you're paying tuition and stuff. And it'll be really clear if you haven't done any of this stuff, because we're going to move pretty quickly. So over the weekend, you're supposed to watch these videos. You might actually have to rewatch 1 or 2 of them again and follow along as you go. But at the end of the day, what we're going to talk about is similar to some of the stuff I showed you before, right? So we're going to talk about just the anatomy of a surface, again, a 2-dimensional sort of terrain, if you will, right? With a curve, we could find a location along a curve and place a point along it with the T parameter. Surface is a little different because it has 2 dimensions to it, right? Just like if we were going to place a point on the surface of the Earth, we would need a latitude and longitude. Similar, in a surface, if to place a point somewhere along that surface, we need a U and a V parameter, right? coordinates. And so that first video talks a little bit about surface properties, and then we actually start to apply those properties in Grasshopper with the next one. Then we do something called using an attractor point, which you can see here. I think I showed you guys that, where I made the surface from a grid of points, and those grid of points move around based on their location relative to this attractor point that I could move around. And then to just rehash some things, right? Remember, we started talking about trusses and making trusses out of curves and points and lines. And now we're going to populate surfaces with trusses, just again to follow up with that. We don't want to forget trusses. They're beautiful, they're gorgeous. And then finally, how we can begin to, similar to how we divided curves, we're going to divide surfaces. And we're going to get all these little checkerboard surface patches and their vertices, and we'll start there when we start to build components on top of surfaces. Okay, so if you think about a surface now as maybe the sort of geometric definition of, let's say, the building skin, and then you want to populate that building skin with, let's say, a rain screen, shading components, mullions, those sorts of things, then it really becomes helpful to take the surface and break it down into lots of little components that we can then populate with those things, right? So, and once again, we'll return to points and lines and curves, because we'll begin to use vertices and curves and things like that on these surfaces, right? But we'll do it once, and then I'll populate it like 20 by 20 or for 400 times, or 15 by 15 for 250, or whatever it is. Can't even remember the square of 15 anymore. That's how sad I am. All right, so anyway, those videos, I think there's 5 of them, are your assignment for the weekend. Okay. And again, honor system here, I don't really have any desire to get more notifications from what do you call it, Canvas over the weekend on my phone every time someone uploads a PNG screenshot of some sort of Grasshopper thingy. You're either 100% invested in your schooling or you're not. Yeah, I get paid either way. Anyway, it's a weird thing to say, isn't it? All right. Anyway, what did you guys think about Akeem? Besides his crazy German accent, which I'm sure you guys got past. Okay, come on. You're all trying to type in the chat box? Yeah. Uh-huh. Feel free to speak up. Your voices are better than mine. Mine sounds like Kermit the Frog, so I could try talking like Akeem Mangas, but then I don't have a very good German accent, do I? No.
I still think the first thing he did with the plywood was the best. That kind of
the plywood shell?
Yeah.
Yeah. Pretty tight, huh?
I thought that was cool. The box that he did later on, I didn't think that was cool. It just looked like a box with shapes cut out of it to me. But interesting how they got there, but visually it wasn't as impressive as the shell.
And then I see a comment from, thank you, Clayton. I see a comment from Richard. The bristlecone project was probably one of the coolest things I've ever seen. Wow, nice. Pretty sweet, huh? So you guys noticed that, like, you know, some of the things that I do from time to time deals with trying to make things move and responsive, and I have to throw like a bunch of like motors and sensors and a lot of money and power at it. And then he comes along and says, okay, well, wood inherently like moves based on moisture and temperature. And then he just like designed something that moves and responds, right? That was pretty sick nasty, I think. I mean, I don't know. Everybody has their own opinion, but I thought that was pretty lit. On a scale of 1 to 10, that was pretty cool. Bristlecone project. Whole thing was very reminiscent of our second year studio project. Oh, the monster. The monster. The monsters? Oh, okay. All right. So, I mean, I think one of the things I wanted you guys to get out of this is that, you know, he is dealing with looking at materials in a very specific way, right? And then he's asking something I think is very timeless in a way, which is once you start to interrogate, let's say, you know, a brand new, relatively new building material like carbon fiber, or you start looking at the properties inherent to, let's say, certain types of wood products, right? Or on and on and on. You know, sort of asking them what they want to be and then designing along with the materials, right? So, and then trying to figure out how complex behavior materials can actually be modeled computationally, right? Because that's a difficult thing to do. You know, I don't know if how many of you guys know like who Louis Kahn was. You guys know, heard of Louis Kahn? Hopefully, you know, like he was an architect, you know, did a few things. Salk Institute, for instance, right? If you're ever in La Jolla, you know, driving back and forth between LA and San Diego, you get past that um, what do you call it, the Marines base, and then finally you see civilization again, right? So yeah, I mean, he had this, you know, famous thing where he asked the brick what he wants to be, and he said, "Brick wants to be an arch," and blah 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 blah. But there's this sort of truth and expression of materials, and sort of utilizing material systems, um, uh, sort of putting together a design with the logic of the material system driving all of your decisions. And to me, I think that's pretty important and an interesting way to sort of think about these things and thinking about how that's augmented through computation. You know, clearly he's found some pretty interesting ways to do that, right? So, what else? Pretend it was like, you know, an episode of Game of Thrones and you're talking about it with everybody like the day after or something, right? Like, okay, like, did you see what happened? And like, you know, with that like freaking plywood, that was rad, you know, or whatever you guys say.
I thought it was interesting that he pointed out that we don't take advantage of the um, flexibility and the variability of the materials. Like, because he showed a picture of all these suburban houses, and they were all rectilinear and pretty boring.
Mm-hmm.
And
Yeah,
then
it's
he
sort of
said,
cookie cutter sort of side of things,
right,
right?
right. And then he said how flexible wood is in terms of design, but we just don't take advantage of that.
Mm-hmm. Yeah, good. You know, what's interesting is that, you know, again, I would agree. Here's what I would maybe throw out there, right? When it comes to, let's say, the form or shape of things, the geometries that are used, they're pretty non-standard things that he's doing, right? But one could argue that they are actually derived from the logic of the material systems that he's working with, right? So for instance, if you ask like what carbon fiber can produce, you know, it's probably not going to look anything like what masonry produces, right? You know what I mean? Like, and then you start to look at, let's say, other sorts of material systems found in nature, like that are woven, right? Like nests and webs and those sorts of things, and cocoons and or whatever you call them. You know, that spiders and silkworms and caterpillars and everything else do, right? You begin to understand that maybe there's a sort of new set of architectures being, you know, being produced, right? And you know, I think it's pretty interesting. Did anybody of you, so I don't know how many of you do this, right? I mean, probably all do from time to time, depending on how interested you are, right? But you like find yourself going, you hear a name or a word or something like that, and you go, what the heck is that? And then you look it up, and you end up on Wikipedia, and then you end up spending 4 hours in the rabbit hole of Wikipedia, like you don't even remember how you started, but you just keep clicking on different links, right? So how many of you guys did that with someone like named Fry Otto? Did any of you guys look that guy up? Because it's interesting. He was a famous German engineer and architect, um, and you know what's interesting is that Akim actually holds his old chair at the University of Stuttgart. He moved there after teaching at the AA in London for a time, and I think what's really interesting is that you know, he's sort of taking that mantra of sort of looking at um, new and expressive engineering material systems and thinking about how those can be applied architecturally and spatially. And what he's done is he's figured out a way to leverage that into like these huge funded projects through the EU, you know, where he designs a pavilion. But what they're really doing is doing a bunch of research. Now, the means of production, did you guys notice that? It didn't look like they just hand over a set of paper drawings to a bunch of builders and humans, and they just start, you know, there's not a bunch of humans out there on the job site putting these things together, is there? What builds these things? You think they produce a paper set of drawings? No, right? Yeah, it's all robots, interestingly, right? And so those robots that you would see on the assembly line at a Honda or GM plant, welding or spraying, or now they have claws and they have router heads and the S-glass tape, the fiber or the carbon fiber tape spindles, attached to them, and they're sitting there weaving or carving or bending or forming, right? Or just simply stacking. And so I think it's a really interesting thing. Did you see, was it the one on here where they actually have to like hand it off to then a quadcopter, and the quadcopter passes the baton over to the other robot arm and then back and forth to sort of weave a sort of maybe that's a different video. But yeah, I mean, it's interesting, like a giant 3D printer that pours concrete. Yeah, exactly, right? A lot of these things are becoming more and more automated. And so he's also exploring and interrogating, right, the sort of formal possibilities that are afforded to us when you have something that is completely driven by digital information, right? So the complexity of, let's say, weaving all that stuff, let's say for the carbon fiber, that would be really difficult. It's possible to do with human labor, but it would be so difficult and so time intensive that it would be, probably unfeasible from a money standpoint, right? And so suddenly the automation side of things, for better or worse, but it's coming one way or the other. You can't just put the genie back in the lamp. One way or the other, for better or worse, is there and lets us do things that probably was too expensive to do, to pay labor to do. Anything else? Any other thoughts about rethinking materiality through computation? That would be a gigantic no. Okay. The interlocking method you use based off the starfish, I think it would mean foam plane mats, but honestly, it was pretty cool, like jigsaw puzzle. Assembly of the machine cut blocks is quite amazing how they interlock. Yeah, I mean, it's just like a little itty bitty detail, right? I think you're both talking about the same thing, right? That those ways of interlocking with just slight concavity, right? Yeah, it's pretty interesting. The assembly of the machine cut blocks is quite amazing how they interlock. And, honestly, part of this is I just want you guys to understand that we have some of these tools in the School of Architecture. I mean, I know it's a little odd, since March 13th, we've just sort of been screwing around on Zoom all day. But, once things are back to normal and you get into those shops and labs with Kyle, we have a CNC router. We have a CNC water jet cutter, or not water jet cutter, plasma cutter with a water bed on it. So we can, cut things like steel, aluminum, wood, plywood, plastics. We have the CNC laser cutter. And honestly, I'd prefer that we're using it so much that they have to buy 2 or 3 more of them, actually. But we have 3D printers, right? So all of these sort of numerically driven machines are there at your disposal, and it's really just a matter of just asking Kyle, and maybe pushing some things in your studios as you go. So anyway, and take advantage of electives. I think I'm going to actually be offering an advanced computational architecture elective in the spring, this spring, hopefully. And I'm not sure exactly what we're going to do, but it's going to be pretty awesome. So what time is it? 10:34. We should probably turn the corner here. And let's just double check on some things here. One, does everybody sort of understand what they need to do over the weekend? We're going to watch these videos. Yay. And you'll try to follow along and divide a surface up into a bunch of little surfaces, right? And if you want to have fun, make this little responsive surface. you always have that graph at your disposal then, and you can save it and keep it along, because it's kind of a fun way to sort of make the form sort of move around and change. You can do all kinds of things when it comes to patterns, whether it's scale, or whether it's the shape, or whether it's moving, or whatever, based off of attractor points. That's something that I just wanted to throw in there, because you'll see that a lot, and I would at least address that in this course, even though we're not really going to use it. When it comes to your own grid shells, I'm going to have 2 different surface classes for you guys to pick from. We'll talk about that on Monday, and I'll actually give you a Grasshopper file that generates this stuff. They'll be based on sine waves, swept along other sine waves. And let me just open that up and show you where we're going here. I'm just going to let Parallels start up here. So Windows is booting. While that's going on, I'm just going to share my screen again. All right, just waiting around like I always do. All right. Sorry, I thought I had this booted already. All right, at least Windows 10 doesn't take too long. Yep. Boy, we started Project 2 in Studio. You guys probably remember this. It took forever to subdivide this UNLV campus into all these, because we had 80 different sites. That was such a pain in the royal pain in the rump. Just put it that way. Come on. I don't remember Rhino ever taking this long to start. There we are.
Is expand, make the little area smaller, or just expand the overall area of the site?
I'm sorry, what are you asking, Caesar?
For the SOAP model?
No, we changed things a little bit. We changed the proportions, mainly because we're not going to, we didn't want to have to like cast everything again. So we figured out what a 5-pound block can be cut down to make 2 different things, and we went with like an 8x3 by 1.5 or something like that. So the 10 by 2.75 by whatever. So yeah, they're divided differently. And then we also had a bunch of other things. We have a bunch of people. It's like 84 sites. I wanted everybody to have a unique site this time instead of having all these doubles. Let's see here. And you know, if there wasn't social distancing, I would have made it the strip instead of campus, like, because then we could get something out of anyway. But let's see, Grasshopper. Oh, again, why is Grasshopper? Maybe it's because I have so many plugins loaded in Grasshopper. I don't know why it's taking so long. Oh yeah, Honeybee and Ladybug. Yeah, there's a lot of stuff in those. By the way, I don't know if you noticed that I have probably more tabs up here along Grasshopper than you do, because I've loaded plugins like Ladybug to do, let's say, sunlight analysis, Kangaroo, which is a physics engine, Honeybee, which does daylighting and wind, Lunchbox tools, and those sorts of things. So from time to time, I might actually encourage you to download specific plugins. For Project 3, we'll actually be using the Rabbit plugin, which is made by Xcode. And we'll be using some cellular automata in order to grow urban blocks. So if you go to grasshopper3d.com, you'll find, or foodforrhino.com, then you'll find a bunch of plugins and things like that. I mean, that's the nice thing about Rhino. I mean, it's not perfect, and I like to go back and forth between Rhino and Revit a lot, but Rhino is actually really responsive to its user community, has a really active user community, and it's opened everything up so that people can actually make these plugins and then share them. And so, I always try to take full advantage of that. Let's see here. Why did I do that? Cancel. Sorry, I'm talking to myself. Shell surface classifications. Right. Okay, so interestingly, here's what we're going to end up with. You'll start with something like this, right? Which you can see is just a sine wave swept across another sine wave in the opposite direction, right? What I'm actually doing is I'm not actually making a curve and then sweeping or anything. What I'm doing is I'm creating a set of functions, right, for x, y, and z, and then plugging those in as coordinates to plot a grid of points, right? And so what you'll find is that, I'm making a grid of points in x and y. And then for the z coordinate, I'm actually plugging in cosines and sine functions. And so they start to go up and down, back and forth in a pattern like that based off of cosines and sines. And then you plug in some numbers to solve for x and y in these functions. And then we end up with a bunch of coordinates that we can plug in for x, y, and z points. Then we take that grid of points, right? And we make a surface from the grid of points. And then what I'm doing is I'm just taking just a portion of these surfaces. So I'm taking two doubly curved samples, right? And one is a dome shape, so a concave shape, right? In which case the curvature in the u direction and the curvature in the v direction are both positive. And then I also give you the option of a saddle shape, right? Where the curvature in the u direction might be positive, but the curvature in the v direction is negative, right? In other words, it's still doubly curved, but the curvature is going in different directions based off of latitude versus longitude, okay? So. And I will just bake both of these at once. No, I won't do it at once. Bake. And I'll bake this one as well. I'll bake it on default. Why not? All right. So I just baked those two patches in, right? I'll go ahead and I just close Grasshopper for the time being, right? So there's one, there's the other, right? You'll have to make a choice which one you want to go with. Yay. I expect roughly, depending on how many of you there are, roughly half will pick one versus half will pick the other. Both present challenges when it comes to the notching. Now I'll show you, and I think I have this almost tweaked enough that it'll work for you. Oh, sorry. But we're going to do some stuff in Grasshopper, but at the end of the day, I'm also going to give you a Visual Basic script, right? This is from my buddy. Oh, come on. There we go. Right? From a long time ago, and he wrote a script that takes all of these, takes a surface and breaks it down into a grid shell and takes all the ribs and populates it with ribs and then unrolls them and then labels them and put notches in them for you. So we'll do some things in Grasshopper and then I'll give you the shortcut here. But what you'll do is you'll run this. You'll pick the surface. You'll tell it how many ribs you want in one direction and the other direction. You'll pick a height or depth for the strip, each rib. You'll tell it how you want them laid out onto the XY plane. Then give it a material thickness for the notches, like 0.05 or something. And then you can see the command line up here. It's doing everything for us. And once it's done, it spits it out and reprints it for us. And so you can see that our, nope, come on now. I just want to select this original surface and just hide it. So you can see that it created the grid shell, and then it also created the ribs with notches, and even a sort of zigzaggy scoring pattern to help make these things a little more flexible as you try to put these into place. Quick question on baking. I don't know why there were times where I couldn't assign it to a layer. It would just bake without giving me that pop-up to select a layer. Why could that be? If you have multiple items selected, it seems to bake it to the active layer. Oh, that's interesting. I didn't even realize that happened. What I do know related to that is if I just select a bunch of things and I go up here to solution and I say bake selected, it'll bake it on whatever the active layer is, like Clayton was just talking about. Whereas if I just right click on one widget at a time and say bake, then it gives me this box and I can select which ones I want. What's interesting is that all of the strips and all of the scores and labels are put on their own layer, which is pretty handy as well. So I had to tweak some things because the labels weren't working right. I think I got into that function. It looks like it's actually making them curves. Yeah, that can be embedded or engraved. V versus U. Yeah. So you'll be getting this script, you know, at some point here. Once we talk to Kyle, start scheduling laser cutter time. Not sure what it's doing. It's really butchering this this poor U and V. That's weird. Maybe I'll try to find a mono stroke font for you guys to download and use. That way, it minimizes the amount of X and Y travel just to engrave these things, right? Because if you have to go around the whole outline of a number and a letter, that's just more cutting time, and the less cutting time, the better, right? Because that's money and time. And so it lays these things out for you nice and flat. You're just one step away from sort of taking each of these and laying them and nesting them together with an 18 by 32 area to sort of make it more efficient to laser cut, right? So, you know, I could start to put these things closer together and try to maximize the yield of the 18 by 32 piece of chipboard, right? I'm going to call Desert Art and let them know that you guys are needing some one-ply chipboard. And someone told me that it's also being sold. Did someone tell me it's being sold out of the AIAS store there on the second floor? Yeah. So, you know, if you guys would rather do that, I mean, I think everybody will need at least two sheets of chipboard. And so, Raymond, I don't know if you're in charge of that or you just happen to know that. I'm not sure who's involved with AIAS anymore. Too many things to remember. Every year I have to memorize another 180 names of students, and somewhere 10 years ago, 180 names fall out of my head and I forget them. I just recognize them on Facebook later on. Does Michaels carry a chipboard? No, I don't think Michaels does, but Desert Art and Blix would. 2 sheets of what size? Well, Michaels doesn't have chip. Yeah, I don't think it does. You're better off. Which Desert Art are you going to? There's one on Sahara, and then there's one on Green Valley. .05. Live way up north. All right. Let's see. It's $2 for 22 by 28. Rainbow in Charleston. Yeah. So again, you know, I don't know if I have even to call ahead, but I might just warn, you know, some folks. But does the maquette, do you guys just get it through Blix, or do you get it through, or do you just buy it from a wholesaler? What do you guys do? Yeah, check online ahead of time. Blix. Okay. You guys prefer Blix over Desert Art? I mean, I don't really care, but like Desert Art always gives me a better price, and I can always get somebody on the phone. Every time I call Blix, they put me on hold, and then they never like come back. It's like, ugh. I like going to Blix though. Yeah, so I mean, you know, go wherever you want. I like the mom and pop local stores better, but Blix, I like Blix too. I mean, don't get me wrong. I don't really have a preference, and that's up to you. Or maquette. So if you're in the neighborhood of campus, maybe just coordinate it with AIAS. So, all right, great. So it sounds like we have some sources of chipboard, but what I want to be clear about is to get the one ply, the 0.05 thickness. Okay, one ply. Yeah, I imagine it's limited hours, right? Especially these days. Yeah, I mean, if you guys have either time or a link, feel free to let me know, and I can always put it as an announcement on the Canvas page as well, okay? But the specs that Raymond just quoted, 22 by 28, I think, is a pretty standard size that you'll find. They'll need to be cut down in order to fit on the laser cutter. For $2, that's not a bad price at all. You can, 0.05, right, is the key, right? That it needs to be skinny. So you're talking just under a 1/16 of an inch, right? 1/16 of an inch is 0.0625. So 0.05 will work well. And that's where I would start, right? One of the things you're gonna have to do is think about that material thickness. So it's listed on the website, Thursdays 10 to 12:30. Okay. I didn't even know there was a UNLV-AIS-the-maquette.square.site. Interesting. Alrighty, I'll pull that up. All right, so that's just letting you know a little bit ahead of time of what's coming up. And then the other thing I will say is, did I show you guys a little bit of did I show you guys how we can use Galapagos and it'll start to populate all the genes, and using an evolutionary solver, we'll try to find the most fit solution for us based off of the performance criteria that we give it. But essentially what we're going to do is something similar to, maybe I can't find it so easily, so maybe I'll just pause there. But what we'll be doing is actually using and measuring the performance of your component systems on these surfaces. You'll fabricate, laser cut those, and assemble those as well. I was trying to figure out a way to make it so that I could give you like the condition that you can't use glue. Make like a more architectural detail, but the scale that we're working at makes that kind of hard. So I'll allow glue this time still. But the idea is that we can also begin to create some of this false color mapping to show, how lighting works with these. If you're coming, email Edith about it. Oh, Edith is in charge of it. Is Edith in architecture or landscape architecture? Yeah, okay. She emailed me and I was like, oh, why are you not in my class? She must be in Phil's class then. She's in landscape. Yeah. All right. All righty. So 10:52, we're actually ahead of schedule. Any other quick questions? Look, I'm super pumped. And what you'll find is that next week you'll actually get a lot more instructions when it comes to designing this grid shell. You'll get some more tools to help you out because we'll actually start putting these things together. And then you'll have more logistics, but also more direction in the sort of constraints of how you're going to laser cut things. And we'll hear from the source himself, Kyle, when it comes to getting the lowdown on how to sign up for time and things like that. Okay, he's done a great job as far as like making all this stuff available to you guys still. In the era of social distancing, I believe there are like dots and tape and signs everywhere on the floors and everything to maintain, make sure that if there is more than one person at a time in the hallway, that no one's going to be within 6 feet of each other. If you just follow instructions, it's a by appointment only, so that there's only going to be a certain number of people in the building at any given time. He has the PPE. He has, and he's constantly disinfecting things, I believe, and so, and honestly, it's one of those things where you drop things off and you can leave and come back in half an hour and hopefully pick them up. So, the idea is that, I lied, the website is, oh, okay. Yeah, this is like a clothing store. Like I picked it up and it's like, it's on Maryland Parkway. Oh no, it worked for me. Yeah. .square.site, the maquette. Oh, well, the other thing, I don't know. It's on Maryland Parkway, so yeah, anyway. Strangely enough. All right. Anyway, oh yeah, there it is. Well, yay. All right.
Josh, when do you think it's the best time to schedule an appointment there?
With the laser cutter?
Yeah.
Oh,
Like
well,
what?
Kyle will tell us about that next week.
Okay.
You know, there'll be certain times, I'm sure. Okay.
Okay. Thank you.
And if there's any special situations that we need to work around, then we will. But all right, anything else before we take off? Okay, then. Class dismissed. I'll see you on Monday. You're welcome for being in class. Doing my job. Yep. Take care, everyone. Have a good one. Have a nice, productive weekend. You too, Tristan. Let me stop sharing my screen. Stop. There we are.
You're still recording, Josh.
Super.